Hello, everybody. So what we're going to be doing today is the graph of the derivative. So the nice thing is that this should be a nice, easy lecture, not like the last one, right, where we had the definition of the derivative, which are all pretty tough problems. This will be nice. So let's talk about the graph of the derivative. So basically, here's the idea. So last lecture, we learned how to find the derivative of a function at a point. Let me say that. We learned to find the derivative of a function at a point. Right? So basically this, given f, no, not that, given f of x, we learned how to get f prime evaluated at some point a. And the apostrophe there, you pronounce prime and it's the derivative. So the derivative of f evaluated at a. Now, if you think about it, we can make graphs of this now. So if you have a function, so you can have an original function, let's say y equals f of x. And of course, you can graph that, right? Has a graph. Well, what about this function? What about the derivative function? Y equals f prime of x. Well, guess what? It has a graph too. And we're going to learn more about that in the next lecture. This lecture is just about what the graph looks like, not really kind of theory about it, like when does it exist, where does it exist, that kind of stuff. We're not going to deal with it too much today. What we're doing today is just, if you have the original function, can you graph its derivative? And it turns out that that's not actually that hard, right? And so the key to graphing the derivative is simply to understand that the derivative is the slope of the original function. So the key is to remember that. F prime is the slope of f. Okay, and that's the key to the whole thing. Because, so for example, so when f looks like this, like what kind of slope is that? That's a positive slope, right? So slope is positive. And if the slope is positive, then the derivative is positive because the derivative is the slope. And f prime is positive. Right? So if f looks like this, so if f looks like that, the slope is negative, right? And also f prime is negative. And the third way it could look is if f looks like if it's horizontal, what's the slope there? Slope is actually 0. Looks like a B, rewriting it. Slope is 0. What's that mean? It means f prime is 0 as well. Okay, and so those basic ideas actually let you draw the graph. I'll show you an example. It's kind of one of these weird problems where actually having more stuff going on the graph makes it easier to do the problem instead of worse. So I'm going to say, graph the derivative. Now you don't actually have to graph any derivatives in the homework for this section. You just have to pick the derivative off of a list. Okay, so I'm gonna graph this, and then I'm gonna have some advice. Okay, so this is y equals f of x, and we want the derivative. So here is my advice. So the first thing to do is going to be find the places where the derivative is 0. Find where the derivative should be 0. How are you going to do that? Well, look back up here. So if it's up and to the right, that's a positive derivative. If it's down and to the right, that's a negative derivative. And if it's horizontal, that is a 0 derivative. Well, we don't have this being horizontal anywhere, but we do have a couple of points where it's horizontal, right? Right here at the top, the tangent line's horizontal. And right here at the bottom, the tangent line's horizontal. So at those 2 points, the derivative is 0. So what you do is right below that, the derivative goes through 0. And right below this one, the derivative goes through 0. Okay? So you're looking for places like that or like that. Okay? So do that first. So the derivative goes through those 2 pink points. The next thing you want to do is say, well, that actually divides up the graph into sections now, because you've got, well, I'll just say it. So the graph is in sections now, and in each section, the derivative should be positive or negative. But it shouldn't change in each section. So what I mean by that is, let me erase these. I'll put them back probably. Okay, so you have those 2 points, right? Well, between them, I want a different color here, hold on. So between this point and this point, right, you have this section of the graph. Well, in that section of the graph, should the derivative be positive or negative? And you go back and you look, right? And we know that when it's down and to the right, that's a negative slope. So this is a picture of a negative slope between those 2 points. But you know it's 0 right here. I want the pink color back. You know it's 0 right here on the left, and you know it's 0 right here. So it's got to go through those 2 points. But in between, it's negative. So what that means is it has to be 0, go negative. No, what is that? So it has to go negative and then come back to 0. Right? Because it's 0 right here, 0 right here, and negative between. So 0, 0, 0, and in between it's below 0. So you do that. Then you say, okay, well, what about this section of the graph to the right? What about this section of the graph? Well, slope is positive there, right? So we got slope is positive right here. So that means the derivative is above 0. That just means above 0. So like that. And then you've got a section of the graph over here as well. What kind of slope is that? Also positive, right? So that means that the derivative should be above 0 over here as well. Now, how do I know that like one of these sections just goes up and keeps going up, right? How do I know it doesn't do this? or like steeper or like that? Like, how do I know that? Well, technically I don't, without a little bit more work. But what I can see is that if it's curving up like this, that means it's getting steeper and steeper, which means the derivative should be going up and up and up. Now you don't know exactly how it looks as it goes up, but you know it does increase. So generally you just draw them the way that I did, okay? So we got three sections of the graph where it's positive slope, negative slope, positive slope. And then you draw those in between those zeros. Okay, let's do more. Let's do more. Another example. Same thing. Graph the derivative. So this is the graph of y equals f of x, and we want the graph of the derivative, which, by the way, over here I should have labeled it maybe like y equals f prime of x. Okay, so again, we're going to do the same thing. So where is the graph 0, or zero derivative? So the only place where the graph is horizontal is, again, at the top here, which I kind of drew it a little lopsided, so I'll draw it right there, a little bit to the left. That's where it goes through 0. And then you've got two pieces of the graph here. Now you have to be a little bit careful. The graph is not 0 out here, but it's close to 0. And the graph is not 0 out here, but it's close to 0. So close to 0, because it's pretty close to being horizontal, but not necessarily completely horizontal there. Just gonna move that out of the way. So close to 0 at the two places where I pointed, it is 0 where I put the dot, and then we just have to decide whether it should be positive or negative in each section. So what about this section on the right here? Slope positive or negative on the right? Well, it's going down, right? Isn't it going this direction on the right? That's a negative slope. So it's a negative slope, okay? So that means that the derivative should be negative over here. So it has to be below 0. Okay, so from the 0 here, it's got to go down and be negative. But then over here on the right, I know it gets close to 0. So that means it comes negative, but then it needs to come back and get close to 0. So it goes negative, right? Let me erase that. Oops, not that. Let me draw this back in. So, so from here, it goes negative, but then it has to get close to 0 again. So it goes negative and then comes back to 0. But it just gets closer to 0. Now, you might be saying, okay, well, I get that it's 0 and close to 0 out here, but how do I know, like, why do I draw that bump there? Like, why? What's that for? Well, if you think about it, the derivative is slope, right? So if you have the slope here, that's 0. And over here, the slope is close to 0. Well, where is the slope steep, right? Like, it's like goes like that, and then it goes like that, and then it goes like that. Where is it the steepest? If you think about that, it's the steepest about, no, I just erased it. It's the steepest about right there. Do you agree with that? Like, it's a little bit shallower, and then it's a little bit steeper, and then it's a little bit shallower, right? So about where I marked it is the steepest. And so if that's the steepest, that's where the derivative would be furthest away from 0, most negative. So it gets, like, the slope gets bigger and negative. Why does it do that? And then from there on, it starts to level out, which means it's starting to go closer to 0, and then it levels out like that. Now the left-hand half is kind of the same thing, but it's all up and to the right here. So that means the slope is all positive on this side. So we can do the same thing. I know it's 0 right here. I know it's close to 0, but still kind of up and to the right over here, so it's like that. And then in between, what's it do? Well, it's got to be 0, go up, and come back. So it's got to basically do this. Same as the other side, but positive slope. But where can we do a little better? Where is it the steepest, right? So it's like that, and then it's a little steeper, and then it's already getting shallower, right? It gets shallower, shallower, shallower. So where is it the steepest? There, maybe? Is that about where it's the steepest? I think that's pretty close. So if that's the case, then the derivative would be 0 slope here at the dot. It's getting more and more and more positive because the slope is getting bigger. And then it's got to starts leveling out, which means the slope is getting smaller and smaller and smaller and smaller. And so like that. And then that's the derivative. All right. Now, again, you're not going to be graphing these yourself. You're just going to be matching them up, and you do things like look for the zeros in the right place. Yeah. Let's do another one. Oh. All right, same thing. Where is the derivative 0? Right? So you look for a place like that. That's where the derivative 0. Mark it there. Now, once you have that, you don't erase your graph. That's wrong. So once you have that, then on the right half, it's up and to the right. And on the left half, it's down and to the right. You wouldn't say up and to the left. We're only looking left to right. So you would say what we just said. Down and to the right, up and to the right. So that means over here, the slope should be positive, and over here, the slope is negative. So what's that look like? Just over here, it's positive and gets more positive, and over here, it's negative and gets more negative. Now, again, you're probably saying, why am I drawing that like a straight line? Right? Like, why did I draw that one like a straight line, but then this one I drew very curved, or I drew the pink one curved, right? Why did I draw the pink one curved there? And why did I draw this one straight for y prime? And so there's a good reason for it. And the good reason for that is I cheated. Okay? You're going to learn, you will learn, that the derivative, when you take the derivative of a polynomial, the degree goes down by 1. So like the derivative of a cubic, right, third degree, is quadratic. And that's why up here, like the original curve, right, looks like a cubic, right? This one looks like a cubic. And that's why I drew the derivative as a quadratic, right? Quadratic is a parabola. So I knew that. And the derivative of a quadratic is a line. So I cheated, right? So I know not to draw that curved because the blue curve here looks like a quadratic to me, looks like second degree. And so I know its derivative is first degree, and that's why I drew it as a straight line, even though I don't really have a reason to draw it as a straight line. All I have a reason to do is say 0 right here, and then positive over there and negative over there. But I don't know really about plus and minuses. I mean about the shape. I know plus and minuses. All right. So that's half of the assignment. Is that? The other half is actually not really any harder. What they're going to do is they want you to think a little bit more about the numbers now on the derivative. So they'll do something like this. They'll be like, where is f prime of x equal to, and they'll give you a number like 5 or something. Okay. And then they give you a curve. And then your curve, you actually, they just give you the whole curve there. And then they'll give you some points. So they'll be like, let me draw that a little better, sorry. So they'll give you a couple points, like they'll go, here's a point, here's a point, here's a point, here's a point, right? And you have to pick the right point and then draw on the tangent line. And so the thing is if you think about drawing in the tangent lines, and you need to think about the slope of a line. So like, let's say I draw a line right here. There's a tangent line. Is the slope 5? It's not, right? That's a negative slope. Could not possibly be 5. Okay? So what about the next one? What if I draw a tangent line right here? Is the slope 5? No, right? That's still a negative slope. Could not possibly be right. So what about the next point? There's the tangent line. Slope 5? No. It's positive at least, right? But if you think about it, how big is that in magnitude? It looks like it's pretty close to 1 over, 1 up. That's close to a slope of 1, right? So it's positive, but looks like it's about 1. It's definitely not 5, right? 5 means over 1 up 5. So let's get a different color. So if you go to that last point and you draw the slope, right, of the curve there, is that one 5? Actually, no, it looks like it's about 3, right? I'm going to cheat. Oh, but if I cheat, oh no. I was going to say if I change that to 3, then I have to change all these to 3. Now I have to erase them and do it again. Okay. 3, 3, 3. Are they 3? No, right? This last one does look like it's about slope 3, right? Because a slope of 3 would be 1 over 3 up. And that's about how steep I drew it, right? So this last one would be the correct one. Oops. Okay, and then that's how you do those. So you should be able to easily figure out, positive slope versus negative slope. And then once that will rule out like half of the points that they give you. And then out of the ones that are left, you're looking for the right magnitude. So how steep is it, right? Let me do one more of those, and then I think that'll be it because this really is just not a very long section. All right. Where is slope? Or sorry, not slope. We're referring to it as derivative. Where is f prime of x equal 1/2? Okay, so let's go here, 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 here. All right, so we got these. So again, maybe the best way to do this is actually like when they say like this, you should think about what that would look like. Like, so when I say slope 1/2 is that's 1 over, or sorry, 1 up, 2 over. So you're looking specifically for a slope like this, right? About like that. So this is wrong, right? Because that's 0. This is wrong because that's negative. This is wrong because it's horizontal. So by the process of elimination, it must be this one, right? So this would be the correct one. Here. Okay? And you know, this one would have been easier too if I had just drawn what a slope of 3 looks like before I started, right? Where does the slope look like that? Then I could have easily figured out that it was that one. Okay? So you just have to think about those. I'm going to erase these and then draw them back in. And if you can do that, then you can do this whole assignment. Pretty easy. Okay, so you're just thinking about the magnitude of the slope in that case. And they make you draw this little line in too, by the way. They make you draw the line in the right place. So you need to know what a tangent line looks like. So pay attention to the tangent lines that I drew. So the tangent lines, remember, they when you're drawing one, just okay, that's crooked. I don't even care. So remember when you're drawing in a tangent line that if you have to put one in a particular place, what it's supposed to look like is it just barely touches and the slope should match, right? So it looks about like that. It shouldn't really cross through the curve right there. And right here, the slope of the line and the slope of the curve match, right? Slope of line and curve match if it's a tangent line. So just keep that in mind when you're graphing these. But you don't have to get it perfect, you just have to get it kind of close when you're graphing them for the computer. Okay, well, I think that's it for this lecture. So, you know, good luck for that on this. And we'll be doing more derivatives in the next section.